We're now jumping into logic, basic logic, logic 101 is what I want to call it here. And really it is formal logic. So how can we calculate outcomes of various combinations of logical values? So this is what we'll go through now. Use formal logic to connect multiple conditions and calculate the outcome for different value combinations. Note that in these tables that we'll be working through now, A and B are variables that can take the value 0 for false and 1 for true. So you can see that down here. A, the value that is given for A can be 0 or 1. And then the expression not A can be calculated from these values. All right, so let's do that. If A is false, then not A should be true, right? It's the inversion of the value. And therefore, if A is true, not A would be false, right? That operator is useful in many settings where you have something given and you just want anything but that, right? Like that's basically perhaps a verbal equivalent for not A. The operators here are given, there are different operators for different programming languages. In Python, it's not, N-O-T. Okay, the next operator is and. We want to combine A and B and figure out when that condition of A and B is true. So if A and B are both false, then their combination should also be false. If A is false and B is true, their combination is still going to be false. That is basically the definition of the AND operator, right? A and B are only going to be true when A and B are true. So if we swap this around, A is true, B is false, we still get false. And we only get 1 here when both the condition A and B are met. So that is often the case that you want, if you're doing some geographical calculations, you want the latitude to be larger than some value and the longitude to be larger than some value to maybe exclude part of the globe. You would test for that with an AND operator. The next one, third one, is OR. This is going to be true when A is true, B is true, or both of them are true. So when A and B are both false, then OR is going to be false. And if either A or B or both of them together are true, we're getting ones here. So this is a condition where we want to make sure that at least one of them or both of the conditions are met. The last one is XOR, or exclusive OR, and that is only going to be true when either A or B are correct or true or met, but not for both of them. That is a thing that occasionally comes up, right? You want to make sure that either A or B are true, but if both of them are true, you do not want to proceed with your calculations here. It's useful to spend some time with these logic tables. We'll have a homework related to that. And try to come up with your own natural examples that perhaps could help with this. We have a couple of here. So the example is, if red and green, then yellow. Note that this kind of pseudo language here that perhaps could also be understood as pseudocode. So we have two variables, one that indicates that something's red, the other one indicates that something's green. If both of these are met, if something's red and green, then it would be yellow, right? So we're testing with the AND operator, and if we work through this here, we will get yellow only when red and green are both true. If it's neither red or green, it's certainly not yellow. If it is green only and not red, well, then it'd be green. If it is red only and not green, then it'd be red. And if both red and green are true, then we can call the thing yellow. The second example is if outlier or affected by some unmodeled process, then discard the observation, right? So that perhaps gets us a little closer to analyzing data, right? You have some time series and there's a point that's just way out of the screen here. Or you know that during a certain time period, something happened that you're not accounting for in the model that you have developed. Let's say there's a large step in a time series because of an earthquake, but you're not accounting for that. So you might want to get rid of data before or after the earthquake, for instance. So this is an OR combination here, right? So we want to keep data only if it's neither an outlier nor affected by unmodeled process. So you can look through the table here and perhaps fill that out in your imagination now. The outcome would be something like this. You do not discard the observation only when it is not an outlier and not an unmodeled process. Note what I did here, right? You can actually replace and or combinations by inverting and combining with the conditions and combining with the other operator. Okay, outlier, unmodeled process, both are false. So we do not discard the observations. For everything else, we get rid of it. Spend some time with the logic tables. It'll be important once we get further